In this video, we deriving the expressions for the wave propagation characteristics in a good conductor. So we are deriving the expressions for propagation constant, intensity, impedance, and velocity. So wave propagation of a good conductor, they are having some certain conditions we mentioned here. So main conditions are sigma by omega zeta is greater than 1, so this is important. So also sigma is far more less than 1. So first of all, we derive the propagation constant. So we already know that propagation constant is having the two propagation constant is equal to alpha plus j beta. So this is attenuation constant. So beta is phase constant. So now we deriving the expression for attenuation constant. So this is the attenuation constant equation. So I already said that good conductor having a one condition, important condition, that sigma by omega zeta is greater than 1. So we write this equation as omega square mu zeta by 2. So here root square will cancel, and also we cancel the omega square and zeta. So finally we get sigma mu by 2. Sorry, omega. So we omega we write it as 2 pi f. So 2 pi sigma mu by 2 f. So here 2 will cancel. So finally we get that. So attenuation constant is equal to root of pi f sigma mu by mu. So next we want to derive the phase constant beta. So phase constant is given by this equation. So according to, we already said one important thing, that sigma by omega zeta is greater than 1. So difference between these two equations, propagation constant, phase constant, are this having considering of plus 1. So we see this is having a minus 1. So as this, so sigma by omega zeta is greater than 1. So square root will cancel. Okay, here omega square zeta will cancel. Finally we get omega sigma mu by 2. Omega equals to 2 pi f. So we write it as 2 pi sigma mu by 2. So here 2 will cancel. So beta is equal to, sorry I forgot to write f. So root of pi f sigma mu. So this is beta. So next is intrinsic impedance. So this equation is given as root of j omega mu by sigma plus j omega zeta. So the denominator term we write it as this. So here if we multiply this term with this term, we finally get this equation only, this term only. So j omega mu, if we multiply this, j omega zeta will cancel. So we get sigma. If we multiply this with 1, we get as it is. So we already know that sigma by omega zeta is greater than 1. So to solve this equation, we write it in this form. Okay. Intrinsic impedance is equal to j omega mu j omega zeta sigma by j omega zeta. So here zeta will cancel. So finally intrinsic impedance is equal to root of j omega mu by sigma. So the final one is velocity. So velocity is given as omega by beta. We already derived the beta phase constant. So we taking beta as root of omega sigma mu by 2. So we see here. So we are substituting beta value in formula. So omega by root of omega sigma mu by 2. So omega we writing it as root of omega root of omega. If we multiply these two means square and root will cancel, we get omega only. So here we write it as this. So here root of omega will cancel, and in denominator if we inverse means root 2 into omega. So this will write it, we will write it as root of 2 omega by sigma. If we inverse this in upper side, we root 2 will multiply here. So it will as root 2 omega. So denominator we have sigma mu. So velocity is given as 2 omega by theta mu. So this is the final one. Thank you.